you picked up 2 sheets. This first one here, it talks about inverse square root functions. All right, what I want you to do is graph y equals x squared minus 2. I want you to predict what the equation or the inverse of this equation will look like on a graph. So think, after you get this graph, predict what you think the inverse is going to look like on the graph. Based on yesterday's work, how would you find the equation of the inverse? And then work with your partner to write the equation and then graph it and see if your prediction's correct. Okay, you get about 7 minutes or so to work on that, if we need that much. Here we go. All down. All right. So excited to teach. All right. Inverses and square roots. So the first one, we're going to graph this. Hopefully it was pretty easy. The y-intercept is at -2. We go over 1 up 1, since a is 1, over 2 up 4. Over 3 up 9. So what is that? 7. I think that's right. Yep. Okay, reflected across the axis of symmetry. And all right, I think I've got it there. So since this is continuous data, we will actually connect the points. If it was discrete data, meaning the stuff in between the points is non-existent or couldn't work, we wouldn't connect them. So there we've got it. Okay, how many got the graph correct? It looked like most of you had that. Now here's where it got a little different. Some of you are doing your predictions. That's good. Some of you drew them in. Some of you actually maybe just talked about them. But based on yesterday's work, how do you find the equation of the inverse? What do we do to do that? Yeah.
We switch x and y.
Okay, Gabby says we switch x and y. So if we want to find the inverse, we are going to switch x and y. So we now have x equals y squared minus 2. Are we agreed on that? Okay, so if we're going to do that, that means I add 2 to both sides. I get x plus 2 equals y squared. And then we take the root. So it's kind of reverse order operations when you're getting y by itself, right? We now take the root, so we get the square root, the plus minus, square root of x plus 2 equals y. Everyone get that as your inverse? Yeah, everyone see that okay? Now, I'm not sure that maybe helps you graph it per se, but I will tell you an inverse is when our x and y values switch. So some of you may have figured this out yesterday when you're graphing. Kind of the easy way to graph is to just find these coordinates and switch them. Right? If this is the ordered pair 0, -2, then I should be able to take -2, 0 and put a point, and that's my new vertex. Right? You just switch x and y. And if this is the ordered pair 1, -1, I should be able to go to -1, 1, and that is that point. So like if we called this point A, this would be A prime, or A prime, not A inverse, okay? If I called that point B, this would be B prime. Is that big enough for you guys? Let me zoom in on that. Okay. Oh, that was really good. Try that again. There we go. Okay. And let's say this is point C at ordered pair 2, 2. I should be able to go to 2, 2. Crazy. And that's also C prime. So that point they have in common. Weird. Okay. And if I called this point D at the ordered pair 3, 7, I should be able to go to 7, 3, and that would be D prime. Okay, and so that would give me one side of my parabola tipped over. Now I missed my point there a bit, but okay. How many are with me? Any questions so far? All I've done is switched my x and y values. So I found the coordinates, switched the x and y's. So for instance, -1, -1, still at -1, -1. Okay? Yeah?
That won't work with the equation because it has the square root.
Let's get there, okay? Let me finish what I'm doing with the graph first, okay? And then we will talk about the equation. All right?
Graph it sideways and use patterns.
Like I don't know.
Like
Like.
turn the paper.
All All right. Negative 2, 2. Negative 2. Okay, so 2, negative 2. All right. Some of you guys are just getting a little too anxious, so I'm just reflecting these points. So I think all right. How many of you have that? I know a few of you had it because I saw it on your paper. Now, yesterday I said we were going to do parabola tipping, and really that's all we've done is we've taken that parabola that was like that and we've tipped it over. Right? So really, same thing, it's just tipped over now. Okay? It's still reflected over this line. The y equals x. That's why c and c prime and this point here and its reflection did not change because they lie on that line. Okay? They're reflected. This point right here, if I were to draw a line from B to B prime, remember they cross at a right angle and they're the same distance away, same thing here. Now, if you were to graph this on your graphing calculator, this equation right here, this is the inverse. Everyone agrees with that, right? If you were to graph this on your graphing calculator, many of you would just see a half of this parabola. Okay? Everyone take your graphing calculator out. I want you to graph it. Put that equation in and graph it. Lee, is this what you're talking about? Come on, dude. How's it going? How's it going? Okay. But no, I still need to talk to you. It is about the calculator. Okay. Hey, question came up by Hannah. How do you put in plus minus? Well, you don't. Okay. We put in x plus 2. Now that is that the positive or negative? Positive. Positive. So if I hit graph on that, notice I get that only top part. That's a function. It passes the vertical line test. Whereas actually if you look at this graph we graphed, when we tip it over, is that a function anymore? No, it's not, because it does not pass the vertical line test. Okay, now that's a key point. Is this a function? No, I see about 1/3, maybe 1/4 of the class messing around with their calculator. Quit fooling around with your calculator and listen now. This is not a function. It doesn't pass the vertical line test when you tip it over. This is a function, but notice we only put the positive value of it on there. Okay, still have 5 of you messing with your calculators. If your neighbor cannot leave their calculator alone when I'm talking, take it away from them. Okay? All right. If I want to put the negative value in, I'm going to go down here and I'm going to push negative. So hit the negative symbol, not the minus, the negative. We're going to go to square root and we'll put the same thing in. So you actually put it in as 2 different equations. Okay? And now when you hit graph, you'll see the bottom portion. Okay? Once again, that is not a function. It doesn't pass the vertical line test. Okay? One or the other is a function. Like if I get rid of the equal here and I just graph the negative portion of it, notice it only gives me the bottom part. The positive gives me the top part. Yes, the negative alone is a function. The top alone is a function. The positive. But both together is not a function. Okay? Any questions? Yeah?
Like on the test, could you just say like, you know, basically, I mean, it is, I mean, they're both separate equations, but like put together it shows like the parabola, but by itself for 2 different equations. I mean, it's kind of reading what you were saying, but I mean.
Yeah, if you're actually saying it's not a function because it doesn't pass the vertical line test when they're both together, that's okay. Generally, you're going to graph one or the other, and usually it's going to be the principal square root. For those of you who don't know what the principal square root is, it's something you'll probably read in a book at some point in your life when you're studying your math class, maybe in college. Principal square root is the positive square root. Okay? All right. Any questions on that? Okay, one last thing. You'll notice this right here. If I have the graph, actually, let's do this. I'm going to turn that over. I'm going to go and just focus on the top part of this graph. Okay? The x plus 2. When I graph that, where is my vertex? Yeah, so if I have y equals the square root of x plus 2, my vertex is at negative 2 what?
0.
Good. HK is negative 2, 0. Okay? notice my h is right here again. Once again, it's coupled with x in some way. My k is out here, which in this case is 0. So it's really the same. It's the same type of graphing we've done in the past. When you're dealing with vertex form for a square root, it's y equals a times the square root of x minus h plus k. It's very similar to a quadratic, right? It's just rather than having parentheses and a squared, you have a square root symbol. Whatever makes this 0 in here is your h term, or is your h. Whatever's on the outside is your k. And then rather than going over 1 and up 1 and over 2 and up 4, rather than going, we go up and then over, right? Because you're switching x and y around. So we're going to graph some of these together here. What I want to do is take a look at number 22. You can graph it either on your note page that I gave you, or you can graph it on the graph paper from yesterday. Yeah?
My calculator doesn't want to graph it. He's graphing mine.
You forgot x. You have an x?
Yeah.
Oh, let me see it. Yeah.
When you graph it, you like the lines in.
It says graph each function. Matt, I got one for you. You want it? You're gone yesterday. Come and see me now. I'll give you your paper. Okay. Number 22. Graph each function, state its domain and range. Here you go. Jaden. Matt.
Are we going up to this now?
No, that's not your quiz.
Oh.
Oh, it is on this.
I don't know if we're going to get to the quiz today now. We may have to do it Monday. I was hoping we would. We'll get it done eventually. All right. What's my h? H is -2. What's my k? Good. -2, 1. H is right in here. K is right here.
H should be 2.
Yeah, h should be 2. It's whatever makes that positive. There we go. So that's positive. Or whatever makes that 0. Okay? So 2, 1. So we go to 2, 1. Right there. And then rather than going over 1 and up 1, we go up and over now. And rather than going over 2 and up 4 times a, we're going to go up 2 and over 4 times a. So it's just flipped of a parabola. Okay? Rather than going over 3 and up 9, we go up 3 and over 9. Oops, 9 is not right there, though. 9 doesn't fit on here, does it?
No.
I'd have to have a few more. It'd be like over here somewhere.
Actually, it's just.
Okay, is it just here?
I think it's
Yeah, it's just there. All right. It would be at 11. So, but anyway, so it's just complete flipped of a parabola. It's an inverse of it. Okay, and since we're only graphing the positive portion, we only graph the top. We don't graph the bottom. Get your arrow on it. Is that a function?
Yes.
Yes, passes the vertical line test. Are we done? Oh, it says state its domain. What's domain mean? X. What's range? Y. Notice domain is another name for X. Range is another name for Y. Notice alphabetically D becomes before R, just like X comes before Y. Okay? And those of you here this summer, you did this. We talked about domain and range. Okay? Domain is where X starts. So if you just focus in on this axis right here, just focus in on the x-axis. As you're cruising down the x-axis, walking along this street called X, you get to 2, and your graph begins. Okay, and it keeps going for the rest of its life. So beginning at x equaling 2, your graph begins, and it keeps going for every value bigger than 2. So when x is greater than or equal to 2, because it could be 2, That is your domain. That is where x exists. I want you to write your range now. What do you think the range is? Yeah. Okay, well, let's see. Here is the street called Y. I've actually seen a Y street and an X street. Just saying. They're not make-believe. Okay? And as you're cruising up Y Avenue, well, I just changed it. Okay, you're cruising up Y Avenue. When you get to 1, you start, right? That's where the graph actually starts existing. And then as you keep going, it keeps going forever. Now, it's going up a lot slower than it is on X. But it starts at 1, and for every value bigger than 1, we have our range. Now, you'll notice that 2 and that 1 could also be found right there. Right? When x is equal to or greater than 2, when x is or y is equal to or greater than 1, you got domain and range. Okay? Yes?
So will it always be equal to or greater than, since we're only graphing the positive?
It's not because you're graphing the positive. If I was to graph the bottom part of this,
It'd be less than.
which one of these wouldn't change? X, right? I mean, x would be the same. It'd be if I was graphing, now we're not graphing this, but if I was graphing this bottom chunk, x still stays greater than, but y then changes to less than. Okay? In order for x to change to less than, what has to happen? It has to rotate this way. Huh? That happens. We're not going to go into it right now. If you want to experiment with it on your calculator, you figure out how it happens. Yeah?
So since it's a function and we only graph the top part, then what would it say for us to graph the whole parabola?
If it said for the whole parabola, you have to have plus minus here.
Oh.
Yeah. Since it's positive, you only graph the top. Any other questions? Okay, one more. Number 8, mixed side. Read the directions. Go ahead and complete it with your groupies. Our assignment is going to be the example side today, 34 and 35. I know there are a lot of words. They're not that difficult.
We're not supposed to do 22 through 32.
And the mixed side, 2 through 13 and 35 through 40. Okay, so not a lot, but there is some. And now Lee can number her paper correctly. You should have enough grids to complete that.
2 through 13 and what else?
35 through 40. Okay? That is your assignment today. Now you know. Knowing's half the battle. The G.I. Joe would say. All right? Good. Contrary to Colt's want, we don't have to do anything else on the example set.
Shut up, Colt. 1950.
All right. I'm just joking. H is what?
Oh, H.
K is?
6.
Dude. 8. Okay, K is -6. What's H?
-2.
-2. Thank you. All right, it's a positive, so it should be going up on the y-axis. Okay, we go over 1, up 1. Or excuse me, up 1 over 1. Up 2 over 4. Up 3 over 9er. And voila. Nothing to this, man. Now, this gives some weird directions, though. It says use translations of the graph y equals root x and y equals root negative x, or negative root x. All that's saying, in other words, they're saying if you had the parent function, y equals x, if you had this parent function, how do these things shift it? Well, that's how we always graph. So this is we're always doing this. You just don't recognize it by that instruction. You're sliding this down. You slid it down 6 and over 2. And now it's there. Pretty cool, huh? Yeah. Yeah, so in other words, you just graph it like you always do. Yes.
Why do they have to tell us that?
Because some people don't use the cool method that we use. Some people use the uncool method of making a table, which isn't that uncool. It's just more difficult. You'll get plenty of making table work later. All right. Tell your neighbor how number 9 is going to look different. Why is number 9 on the mixed side going to be different?
Because it's going to be flipped upside down. Negative.
Like 1, 1, and then 2, 4, like you just square it. 3, 9.
Okay. Hey, what's H?
2.
What's K?
3.
Okay. So we go to 2 and then to 3. How does this one change? Yeah.
It goes downward.
Yeah, it goes downward because of the negative, right? So we go down 1 over 1, down 2 over 4. Is that 4? Okay, down 3 and over 9, which we can't fit on here. So, okay, and there we got it. It goes down. So that's a translation of this one, right? That parent function would be right here. And all it's been done is slid over this way and up 3. Okay. You don't have to show that. No. No. You don't have to show that. I'm just pointing out what the directions are showing. Okay, rate yourself 1 to 5. All right. Here's a common error that students make on their assignment last night. Just so you know. Some of you made it. Some of you will make it right now, but let's see if we can do number 98 and 99. You're lucky I didn't assign those two. Okay, 98 and 99, find the inverses of those. Hey, let's see how you did on this first one. Switch them around. That becomes x equals y squared minus or plus 4. And just subtract 4 on both sides. We get x minus 4. Kind of reverse order operations, right? So usually you deal with the square and then the 4, but when you're moving things around, you go reverse. You deal with the 4 and then the squared. Okay? So when we take the square root, we get x minus 4 quantity squared, or excuse me, the square root of that. That's a plus minus equals y. Now, can we take the root of 4? No. This part is tied together with implied parentheses. So it's tied together. You have to leave it like that, and we're done. How many got it? Okay. Common mistake on number 99. 99, students, and you guys had some like this yesterday. Students start multiplying that out. They FOIL it. They get x squared plus 6x plus 9, and then minus 6, and that is wrong. Don't do that. It makes it way tougher than it has to be. Okay? So, reverse order operations. Do you deal with parentheses, exponent, or minus first if you're going backwards?
Minus.
Minus. So let's add the 6 first. Oops, I guess we should switch it around, right? Let's do inverse. Okay, so inverse would be x equals y plus 3 squared minus 6. All right, now we will add the 6. So x plus 6 equals y plus 3 quantity squared. Now, do I deal with the 3, so the parentheses, or the exponents if we're going reverse? Exponents, right? So how do I get rid of a squared? Square root. Plus minus there. And now you've unlocked the parentheses. So this is like your key to the parentheses. And now what do we do? Subtract 3. Now I would put the negative 3 out here. just because, well, there's two reasons for it. You'll understand a little more when we get to later in the chapter, but I would put the -3 out there. That's kind of the form we use. And the other reason is if you have it looking like this, it's hard to tell where your radical is supposed to end. You're like, well, is that supposed to be in there or no? I don't know. Okay, so I tell students, if you're going to put it like this, you better kind of show a blocker or something to your radical so I can tell, okay, that it ended there. I would suggest like this. This is the proper form. Okay? Any questions there?
Would it be fine if you said y equals -3 plus or minus square root? Like
Yeah.
this is the opposite.
Yep. Yeah, you could write it like this. Well, if you can write it without making a mistake. Okay. Either one works. All right. So, your assignment, you guys have it? Go at it there. What is due on Monday besides your assignment?
Portfolio page.
Portfolio page.